Hey, geometry. So last part of section 7.2, we're going to do how this similarity stuff relates to perimeters. And so if two polygons are similar, then their perimeters are proportional, just like the sides are. So they're proportional to the scale factor between them. So, if we know that ABCD is similar to ABCD is similar to JKLM, then we know that all these ratios should be the same, right? AB over JK, that ratio, that scale factor between those is the same as that fraction is the same as BC over KL, so BC over KL. That's going to be the same scale factor between them, and CD over LM and 8DA. Trying to go all the way around here, all four sides, over MJ. All four of those fractions will be the same. Maybe they're 1/2, 1/2, so on and so forth. Well, if you add all those up, then they're also proportional. And so that should be equal to AB plus BC plus CD plus DA over JK plus KL plus LM plus MJ. Right? If these are all 1/2, then like 1/2 and 1/2 and 1/2 and 1/2. Well, if I add 1 plus 1 plus 1 plus 1, that would add up to 4. And then if I add 2 plus 2 plus 2 plus 2, that adds up to 8. So we have 4 over 8 ends up being 1/2. Likewise, we could do that with any fraction. We end up with that same ratio between their perimeters. So a couple of scale factor perimeter problems. If ABCDE is similar to PQRST, find the scale factor of ABCDE to PQRST and the perimeter of each polygon. So here we've got this figure. They didn't label a lot of sides, but they marked some congruencies for us. So this is actually, if that's 8, this is 8. If that's 4, this is 4. Kind of makes that figure all work out quite nicely. They didn't mark congruencies here. I don't know quite why, but we do know that if this is 3, for instance, this also has to be 3. Because if they're congruent in this figure, they're going to be congruent in that figure with similarity, right? These top two are congruent to each other. So scale factor, I can go this 4 to 3. So we know the 4 to 3 is our scale factor. So that's, AE to RS, that's our scale factor. And that is, ABCD to PQRST. And so we should be able to figure out all the sides. And so they want us to figure out all what ultimately the perimeter is. I could go through and figure out the all the sides over here. I could say, oh, that's 3, and I could do the scale factor, 4 to 3 for this one, 4 to 3 for that one, 4 to 3 for that one. Instead, we don't have to do that. We can just go perimeter here. So we can add 8 plus 8, and I'm just going to do this. This is the perimeter of A, B, C, D, E. So it's going to be 8 plus 8 plus 4 plus 6 plus 4. And so we can add all those up. And so when we add those up, we get 30. Did I do that right? 16, 20, yeah, 30. And then that we should be able to set that up and solve that. That should match the perimeter. That should match the same scale factor for our perimeter of PQRST. So perimeter of PQRST is unknown. So we can say, we don't know what that perimeter is. I could call the perimeter X. Well, that should match that same 4 to 3 scale factor, going from this perimeter to that perimeter. And so this figure, the sides are a little bit bigger. I expect this perimeter to be a little bit bigger than that. And so we can then set up and solve this. 3 times 30, 4 times X, so 4X equals 3 times 30, which is 90. And so then if we divide by 4, 90 divided by 4 is 22.5, or you can write the reduced fraction, but that is ultimately our perimeter of PQRST. So we got the perimeter of the first one is 30, and then this one is, that's our perimeter of PQRST. Perimeter of PQRST. Yes, we could have actually gone through and done the 4:3 ratio, the 4:3 scale factor from this. So like that would be a 3, and then 4:3 for this, and figure out what that decimal is, and 4:3 from that. And so these would actually both be 6s. And it wouldn't be that terrible, but just want to show you can do that in terms of perimeter as well. Last one, if MNPQ is congruent to XYZW, find the scale factor of MNPQ to XYZW and the perimeter of each polygon. So I'm going from this one to this one, MNPQ to XYZW. So a little kind of offset and spun around. So the one thing we have over here is WX or XW. So I've got like the first to last. So let me. It's kind of sometimes hard to find the corresponding part over here. And I could go through and mark the angles congruent. That might help because then I can see, oh yeah, angle X is congruent to angle M and angle W and so on. You could also do that, but you can do it in the letters here. So I've got XW. The corresponding side is QM. So QM, and I'm going to do this here, and maybe you could call it QM or MQ, and that's our QM to WX ratio. And that is going to be our scale factor for these two. So I know that's the side corresponding to that one. And so 8 to 4, that ultimately is a scale factor of 2, or 2 to 1. This thing is twice as big as this one. So add up its perimeter. So the perimeter of MNPQ is 8. I guess I can go in MN order, MNPQ. So I'll start with the 9 plus 10 plus 7 plus 8. So if I add all that up, my perimeter of this one is 34. And then we know the same thing, we can kind of set up, but we know it's a 2 to 1 ratio. So 2, I'm going to write this as 2 over 1 is equal to 34 per, and then X is going to be my perimeter of XYZW. So setting up and solve, 2x equals 34. X is 17. And so that's my perimeter of XYZW, and then that's my perimeter of these. So 34, that one's 17. And so we can solve that more quickly instead of having to solve for every single side by setting up each ratio and doing all that.